NOAA now says there is an 81% chance the 2026 El Niño reaches the very strong category between October and December. That would put it in the same class as some of the biggest El Niño events measured since 1950. But this is not an 81% chance of a worldwide disaster. It means the Pacific climate engine is shifting hard enough to tilt weather odds thousands of kilometers away. Rain can move away from one region and concentrate over another. Heat can build where a normal year would release it. And local forecasts can still break the expected pattern. So what exactly is accelerating? Where do the strongest signals point? And what happens next? Start with the speed of the change. In February, NOAA's latest weekly reading for the Central Pacific was minus 0.9 degrees. That was La Niña territory. By May, the same weekly index was plus 0.4. On July 9th, it had reached plus 1.2. Farther east, the ocean off Peru and Ecuador was already plus 2.7. Those are not temperatures of the water itself. They are departures from what is normal for each place and time. Beneath the surface, a pulse of warm water called a Kelvin wave traveled east, pushed the boundary between warm and cold water deeper, and weakened the ocean's ability to cool itself through upwelling. WMO's latest multimodal average now puts the July to September seasonal anomaly near 2 degrees. In 5 months, the Pacific did not merely cross a label. The ocean and atmosphere began reinforcing the move together. Here is the engine. In a normal Pacific year, trade winds blow from east to west along the equator. They push warm surface water toward Asia. Near South America, colder water rises from below to replace it. That upwelling carries nutrients, cools the surface, and helps keep the heaviest tropical rain in the western Pacific. During El Niño, those trade winds weaken and can sometimes reverse. Warm water spreads back toward the central and eastern Pacific. Upwelling weakens. The zone of rising air and heavy rain moves east with the warmest water. That relocation changes the Walker circulation, the enormous loop of rising and sinking air wrapped around the tropics. The shift then nudges other circulation patterns and jet streams. That is how a strip of ocean near the equator becomes a global weather signal. The water moves the rain moves the air. The air changes the odds far from the Pacific. So what does very strong actually mean? NOAA measures the event with a 3-month running average in the central equatorial Pacific, adjusted against the wider tropical ocean. El Niño begins above half a degree. The very strong category begins at 2 degrees. For October through December, NOAA's official table assigns 81% to that top category. It stays at 75% for November through January, then falls to 54% for December through February. History gives that scale some context. The 1982, 1997, and 2015 events all peaked around 2.4 to 2.5 degrees in the same adjusted record. One experimental NOAA modeling system is even more aggressive. All 30 of its July ensemble members produce a peak competitive with the strongest events of the past century. That is a serious signal. It is still a forecast range, not a promise. Now follow the chain reaction. The first move is local. Rainfall shifts toward the unusually warm central and eastern Pacific, while sinking air becomes more likely over parts of the maritime continent. The second move travels through the upper atmosphere. Extratropical heating changes the Hadley circulation and bends storm tracks. The third move appears on regional seasonal maps. Some places become more likely to be wet, others dry, and vast white areas remain too uncertain to color at all. Meteorologists call these distant links teleconnections. They are patterns found in both models and observations, not remote control commands sent by the Pacific. A stronger El Niño often makes the familiar pattern more likely. It never makes every piece inevitable. Think of the ocean as loading the dice for an entire season. It changes the odds on each face. It does not choose the number on the next roll. The current regional forecasts make that distinction visible. India's weather service expects July rainfall across the country to finish below 94% of its long-period average. That average is about 280 millimeters. But the same map shows exceptions in parts of Northwest, Northeast, East Central, and Peninsular India. One national headline, many local outcomes. Across Southeast Asia, the regional outlook favors below normal rainfall over much of the maritime continent, including the southern Philippines, Brunei, and Singapore, while mainland signals are mixed. Australia's July outlook gives much of the south and west, plus parts of the east, a 60 to 80% chance of below-average rainfall. Yet Australia's own forecasters repeat the warning. A strong ocean signal does not automatically mean a strong local impact. The same El Niño enters 3 forecast systems and comes out as 3 different maps. Zoom back out and the world map becomes a patchwork. WMO's July to September outlook leans wetter over the central and eastern equatorial Pacific. It leans drier across parts of the Indian subcontinent and much of Australia. Across equatorial Africa, the signal splits. Areas north of the Gulf of Guinea lean wetter, while the Greater Horn of Africa leans drier. Central America, the Caribbean, and northwestern South America also carry a drier signal. Europe has a weaker north-south contrast, with wetter odds in the south and drier odds in the north. But WMO marks confidence there as lower. None of this says every day will follow the seasonal color. A dry-leaning season can contain a flood. A wet-leaning season can contain a heat wave. The map describes the balance of a whole season, not tomorrow's weather. There's another reason not to turn that map into prophecy. El Niño is not the only climate driver moving. WMO's global ensemble expects the Indian Ocean dipole to become positive, with a July to September average near 0.6 degrees. India's June 30th outlook expected the dipole to remain neutral during the southwest monsoon. That is not proof that one agency is wrong. They use different model systems, update schedules, and regional priorities. The Atlantic is also unusually warm. Local sea temperatures, soil moisture, mountain ranges, and short-lived weather patterns can all reinforce or cancel the broad El Niño signal. This is why a global center tells you what the planetary pattern favors, while a national weather service tells you what to prepare for locally. Forecast confidence has layers. Confidence that El Niño will persist is high. Confidence in its peak strength is narrower. Confidence in one town's rainfall months from now is lower still. So, what happens next? Through August and September, the Central Pacific is expected to keep warming as the ocean and atmosphere remain coupled. From October through December, the official odds concentrate in the very strong category. El Niño events typically peak between November and February. NOAA then gives this event a 97% chance of lasting into early spring 2027. After the peak, the probability table gradually steps down from very strong towards strong, moderate, and eventually neutral. That decline is also a forecast, not a timer. The next decisive update arrives with NOAA's August 13th discussion, followed by new regional outlooks. The story is no longer whether El Niño will form. The story is how high it climbs, how long the coupling holds, and which regional signals survive contact with local weather. 3 signals will tell us whether the forecast is holding. Watch the weekly Central Pacific reading. Watch whether the trade winds and tropical rainfall keep reinforcing the warm ocean. And watch your National Weather Service, because the local map matters more than a dramatic global headline. The Pacific has already changed state. The 81% figure tells us how much stronger it may become. It does not tell us exactly where the next extreme will land. That gap between a powerful signal and an uncertain outcome is the real El Niño story. Subscribe for the next update. Talk is cheap, numbers aren't.